In triangle MNP, we want to find angle N. So this is what I'm going to mark it right here. This is what I want to find. I don't have a 90-degree angle, so I can't use SOHCAHTOA. I notice that I do have an angle and an opposite side. So I can use the sine law. But this question is a little bit of a problem. Because if I want to find N, I need what's opposite. Do I know the opposite side? I don't. But that doesn't mean I can't solve something else. So this is what you're going to do with a triangle. You're going to look at it. You might want to find something, but you can't solve for it right away. Instead, you ask, what could I solve? Well, these two go together, and I have the 10. Can you see that the 10 goes with angle P? So I could find angle P. Would that help me later on? Sometimes if you can't find something directly, you say, well, what could I find? I can find angle P. Can you see that if you knew the green angle P, you see that you could then find angle N? How would you do that? Well, they all add up to 180 degrees. So in this situation, we have to find angle P first. So if I'm finding angle P, that's what I'm going to put in my numerator. Sine of angle P. What goes with it? Opposite side, 10. Again, we're not worried about the formula having A, B's, and C's, and what's A, and what's B, and what's C. Instead, we're just thinking about always angles go with opposite sides. That makes it really easy. I need to make this equal to something, and the two that I knew, I know that 92 degrees goes with 11.8. So now I can multiply both sides by 10 to get sine of P by itself. And this is where your cast rule and your reference angles are going to come into play, because we're solving for an angle. And if I'm going to type this into my calculator first just to show you that, use my fraction button, 10 sine of 92 divided by 11.8 is equal to 0.8469. I'm just going to write that down. Sine of P equals 0.8469 ... If we're solving, right, back in grade 10, you would just do sine inverse to find the angle, because all of your angles were in quadrant 1. But now, we have a possibility that our angles could be in different quadrants. So we have to use our reference angles and use our cast rule. Can you see for sine being positive, it could be in quadrant 1 or quadrant 2. You might even want to draw, here's my reference angle for P in quadrant 1. Here would be my reference angle for P in quadrant 2. So there's two possibilities for angle P, this one or this one. How do I find my reference angle? I do sine inverse of the positive value, and it's already positive. But it's not bad at this moment to do and think about that little review, right? It was positive, so it wouldn't have made a difference. But for reference angles, if that answer was negative, we always do sine inverse of positive things to find our reference angle. So our reference angle is going to be, go to my calculator, go sine inverse, and I can steal this answer by clicking on it, 57.881. pretty obvious that the one in quadrant 1 is exactly the same, right? My reference angle and my actual angle are the same in quadrant 1. In quadrant 2, does it make sense that you do 180 minus your reference angle? So I could go to my calculator, 180 minus, steal this answer, 122.119. Now, once you solve something, look at your picture. Do they both work? Is this the case where we have two triangles that work? Or is it the case that none of them work? Or is it the case that only one of them works? Why would I do this?
Because 122 plus 92 is a lot more than 180.
It's already more than 180. So if it's not going to work, the bigger one for sure will make your triangle more than 180. Mathematically, both of these work for sine. But in our situation of an actual triangle, only one makes sense. So then P has to be 57.881. And then if you wanted to find angle N, can you see that you can take 180 minus the 92 minus the 57.881. And again, I would go to my calculator, 180 minus 92 minus, and I would go and steal this answer from before, so I have all of its decimal places. 30.119. I keep my 3 decimal places, and I use all my things, then at the very end I read, oh, to the nearest degree. I don't want to lose that rounding mark. So I reread my question at the end, and I get 30 degrees exact. So when solving for the angle, we're going to use our ideas of CAS rule and reference angle. You're going to get 2 possible answers, but only one of them makes sense. Because the other one would make your triangle add up to more than 180 degrees. All right, circle number 4, and take about 5 minutes right now to try these.